Cython converts type-decorated Python into C for performance and for making it easier to use existing C libraries. And a major new revision of Cython is in the works, Cython 3.1, and it promises some powerful new features. So let's take a look. To show off these new features, I've built an extremely simple Cython module with one function in it. It takes an integer, it multiplies it by 2, and it returns the result. This module uses the newer pure Python-style Cython syntax, where Cython's types and special functionality are expressed with Python constructions, like type annotations. This is also our showcase for Cython 3.1's big new features. Most of the new features revolve around better annotations for Cython code, and I've got 3 of them here. The first is the ability to annotate things as constants with cython.const. So in this module, I have m set to an integer constant 2. Note that constants can only be declared at the module level. If I uncomment the same kind of line in our function and try to compile this module, I'm going to get a Cython compiler error. But if I take that line back out, everything compiles correctly. A constant can be pretty much any value we want. It just has to be declared at the top level of the module in order to be syntactically correct. Next, we have type annotations for pointer types. I can use cython.pointer along with a Cython type in the brackets to indicate a value is a pointer to some other value. And I can use the cython.address method to get the address for a given Cython value to convert it into a pointer, although that's not actually a new feature. That's been around for a bit. We also have a type hint for volatile values, and I've used that here to declare this pointer as volatile. The volatile keyword in C is used to ensure that the compiler does not make optimizations that presume what a given value is going to be at any time. It's mainly used for things like interfacing to hardware, so it's not very common. But in certain contexts, it's important, and now Cython lets you annotate your code with it directly. The last new addition is in some ways the most forward-looking. It's the ability to mark a given Cython module as being compatible with the new free-threaded or no-GIL builds of Cython. At the top of the module, I have this declaration to the Cython compiler: Cython free-threading compatible equals true. Now, that by itself doesn't mean the compiler will generate a free-threading compatible module. It just means when the module is imported into the free-threaded build, Python won't automatically drop back to GIL mode for the sake of compatibility. I should also note that Cython assumes we know what we're doing in terms of how threads are handled. This compiler directive is just a way of saying, yes, I accept terms and conditions, let me take responsibility if my module causes a seg fault. Now, to actually make this module compile for free-threaded builds, we need to use a compile time macro in our setup.py file. So here, I detect whether or not we're compiling this module in a free-threaded build. I use the sys isGIL-enabled property to detect this. And if the GIL is in fact disabled, I added the needed macro into our compile instructions. Now, I've already compiled versions of this module for both the normal and free-threaded versions of Python. If you look at the compiled module names, you'll notice one of them indicates it's for 3.13 and the other for 3.13t, and the T is our free-threaded edition. So if I switch into a virtual environment that uses the regular GIL version of Python, when I run my little test program, you can see it imports the GIL version of our Cython module. But if I switch into a virtual environment for the free-threaded version and run our program, it imports the free-threaded build and uses that. Both editions can coexist side by side in the same project if they need to. Now, everything I've demonstrated is only available in the development or bleeding edge edition of Cython that can only be installed from source on GitHub, so it's all in the early stages, just as the free-threaded build of Python itself is an early stages project. But if you want to get a leg up on the process of building Cython modules for free-threaded Python, you can get started right now. So that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.